personal area network, LAN, local area network, metropolitan area network, MAN, wide area network, WAN, wireless network, home networks, and internet network. Here in the table on the bottom right we have some locations processors like square meter, 1 meter, in the room 10 meters like a local area network, and the building 100 meters in a LAN. And we can put campus there in a LAN with 1 kilometer, no problem. We can find the Cat6 RJ45 for the LAN, really cool. Of course, metropolitan area network, which includes cities, wide area network, which includes the country and continents, reaching 100 to 1000 kilometers, and of course the internet, which covers 10,000 kilometers, even more, for the planet. So, what is a PAN? PAN lets devices communicate over the range of a person. It's, for example, a wireless network that connects a computer with these peripherals, like Bluetooth. We have LAN, private-owned network that operates in a nearby single building, like a home, office, factory, enterprise, school, whatever. And so LANs are used by companies like enterprises. They are used in homes, and the companies are really popular because they can really access and are way faster. We have MAN, Metropolitan Area Network, which covers the city. We have MAN like a cable television networks, like Air Broadcast TV, and WiMAX is also another metropolitan area network. We have one wide area network, which is a larger geographical area. Often it includes a country or the continent. And recently we have fiber optic networks, satellite networks, mobile communication networks, and some example of ones which we have private, MPLS, Metro, IPsec, and where we can see others for it. Also the network hardware like wireless LANs, and either triple E. Don't worry about this acronym because they are mainly for engineers where they are located, and what they do is mainly about the wireless definition. 802.11 is the standard definition for wireless. We also have like 3 unlicensed different bands which are used at 902 to 928, 2.4 to 2.5 GHz, and 5.7 to 5.8 GHz. Also, communications are possible using access points or in peer-to-peer or ad hoc manner, which is really cool. Security, of course, is considered WEP, WPA, and WPA2, which is really secure this one. There's also some schemes to address this. So, as you can see the figures on the first image is A, we have the wireless network with the base station, with a wired network, as you can see. And the second image B, we have ad hoc networking, which is really fast and no need for any wire. We have the network hardware, where we have mobile networks, the first generation. You couldn't do anything else except transmit voice calls. And the second generation, you can improve security and text messages. And GSM, which was deployed in 1991 and has become the most widely used mobile phone system, and it was a 2G system. Now we have 3G and 5G 5th generation, which have included internet and a faster connection between two users. Yes, as you said, the 3G system were deployed in 2001, and they of course offer the digital voice and broadband digital services. But also we have UMTS, which is wideband code division multiple access. Is the main 3G third generation system that is being rapidly deployed in worldwide. What we hope in the 5G will be really advanced in the near future. Also, we have the 4 technologies, which are facing the 3G or LTE long-term evolution. We have other wireless technologies, also they offer broadband internet access to fixed and mobile clients, and the networks and common name of WiMAX. We will later on see what WiMAX is and what it does. And it gives some space to LTE, which stands for long-term evolution, but Bill closed it for some years ago. And the fifth generation, which is speeds beyond what the current 4G can offer, which is the fastest we have right now. And also the data rates of tens of megabits per second should be supported for tens of thousands of users. 1 gigabit per second to be offered simultaneously to many workers on the same office floor. Several hundred of thousands of simultaneous connections to be supported for massive sensor deployments. Spectral efficiency should be significantly enhanced compared to 4G. Coverage should be improved. Signaling efficiency should be enhanced, and latency should be reduced significantly compared to long-term evolution. So this is what the next generation defines for following requirements. But what is the internet now? It's a computer network that interconnects hundreds of millions of computing devices throughout the world. As you can see from the figure, this is an example of what an internet is. The internet, of course, is not really a network, but is a vast collection of different networks. They use for common protocols and provide certain common services. It is an unusual system in that it was not planned by anyone and is not controlled by anyone. And this is why internet is more reliable for any user or any user that wants to access it and doing things whatever you want. We have IoT, as we said earlier in the beginning of the lecture. Internet of Things is a physical object that contain embedded technology to communicate and sense or interact with their internal states or the external environment. We have the benefits of them. They can monitor their overall business processor with statistics and whatever they do, the data that they collect. They can improve the customer experience, save time and money, enhance employee productivity, integrate and adapt business models, make better business decisions, and generate more revenue. As you can see some stats, don't worry about these stats, you won't need them. Just check them out, what happened 2003 to 2020. We have to 500 million devices in 2003 to 50 billion devices in 2020. Of course, but how is the data transferred through internet? If we have a large network, there might be multiple paths linking sender and receiver. Information may be switched as it travels through various communication channels. There are two typical switching techniques available for digital traffic. There are circuit switching, which are dedicated for call, telephone net, and packet switching data set through netting, discrete chunks. But what is circuit switching? Circuit switching is a technique that connects the sender and the receiver in an unbroken path. As you can see, circuit switching makes sure that there is no broken path between the sender and the receiver. Telephone switching equipment, it also establishes a path that connects the establisher and the caller and the sender receiver. And this type of switching technique, once the connection is established, a dedicated path exists, and now the both user can connect until the connection has been terminated by them. And also they have the routing decision must be made when the circuit is first established, but there are no decisions made after that time. Of course, now we have the part of packet switching. Each end-to-end data stream are divided into packets. For example, user A and B packets are shared through network resources. Each packet uses full link bandwidth. Resources are used as needed. And we have two methods of packet switching, datagram and visual circuit. As you can see from the figure, A and B, the nodes C, D, E, F, G, H. These are the bandwidths now that we have to go through to send to the receiver. These use the kind of greedy algorithm, if you have learned them from the computer science course, which I have uploaded on my channel. You'll have really easy to understand this if you go through that course. So don't worry about if you understand them. Take a step back and learn it and come back here, because we're gonna need it in the near future. Of course, in both packets, the message is broken in small parts. They are called packets now. They are tagged with appropriate source and destination address. They have strictly defined maximum length. They can be stored in main memory, and they can access delay and cost are minimized. That's why we need the packets. With the today technology, packets are accepted onto the network on a first come, first served basis. If the network becomes overloaded, packets are delayed or discarded or dropped. We have end-to-end resources reserved for call. We have link bandwidth, switch capacity, dedicated resources no sharing, circuit light performance, and call setup are required. We have the DSL Modem, which stands for Digital Subscriber Line. It takes digital data and translates it to high-frequency tones for transmission over telephone wires. The analog signals from many houses are translated back into digital format into the Digital Subscriber Line access multiplexer. So as I said, the analog signals from many houses are translated back into digital format in the Digital Subscriber Line access multiplexers. As you can see from the images, we have the existing phone line 0 to 4 kHz and to 4 to 50. And we have the 1 million downstream data, which goes to the internet and telephone network to the central office. Switches is a small hardware device that centralizes communications on multiple connected devices with a LAN. It is a layer 2 device and keeps a record of the MAC addresses of all devices that are connected to it. So when a frame is received, it knows well which port to send it without increasing network response time, without delaying it. And for routers, is also a device that links computers with the internet, so user can share the connection. It acts as a dispatcher, choosing the best path for information to travel, so it's received quickly. A router is typically connected to the two networks like LAN or WAN to the internet service provider. So thank you for coming to this lecture. Hope to see you soon. And the next tomorrow we have the computer science lecture. So stay tuned.